Okay, today we have antiderivatives. So I could read this whole paragraph, but it'll probably sound confusing to you. So when we took derivatives were able to find the slope of a function at any given point. Well, antiderivatives are cooler because they find the area of a function on a given interval. So if you were, let's say we were to graph, let's say just x squared. So here would be the graph of x squared. Well, antiderivatives find area. So on this interval a to b, you would be finding the area underneath this given function. So that's what antiderivatives do. Now, today we won't be finding any areas. We're just going to be working the definition of antiderivatives and integrals, and then the next class we'll learn how to find area. So with that being said, when we find the antiderivative, we use something called integral notation. So this says the integral of f of x dx will equal capital F of x plus some constant c. And this is true if and only if you take the derivative and get back to the original problem. So everything in here, the symbol, that's the integral symbol. The function inside the integral is called the integrand. The symbol dx indicates that the anti-differentiation is performed with respect to x, and the arbitrary constant c is called the constant of integration. So that c must be tagged along every time we find an antiderivative. Okay, cool. So here are some formulas for antiderivatives. And number one is going to be the most popular formula. This is the new power rule, but this is the power rule for antiderivatives. So instead of taking one away, we now add that one back. So if you're given any function in the form of x to the nth power, then the antiderivative of x to the n is going to be given by x to the n plus 1 over n plus 1 plus c, the constant of integration. So this is the power rule. This is the most popular one. All right. Well, the second one, the integral of e to the x, guess what? It's still e to the x. So just like the derivative of e to the x is e to the x, the antiderivative of e to the x is e to the x. Okay. 3, the integral of 1 over x dx is going to be equal to the natural log of the absolute value of x plus c. 4, it says the integral of k, some constant or coefficient, times f of x dx. Well, what you can do with k is move it to the outside. We were able to do this for limits. We were able to do this for derivatives, and we're definitely able to do it for antiderivatives now. So if you have a coefficient in front or a constant, you can move it to the outside of the integral. 5, the integral of two functions. So if you have the integral of f of x plus or minus g of x, you can split this into multiple integrals. You can make it the integral of f of x plus or minus the integral of g of x. All right, so however many functions are in your integral, that's how many times you can split it up. Number 6 is called the constant rule for antiderivatives. So the integral of some constant k all by itself will be kx plus c. So this is our constant rule. Okay. And then the antiderivative of cosine is sine. Antiderivative of sine is negative cosine. Antiderivative of secant squared is tangent. Antiderivative of secant x tangent x is secant x. And the last two, the antiderivative of 1 over the square root of 1 minus x squared is the inverse sine, and the integral of 1 over 1 plus x squared is the inverse tangent. So we can reference these formulas as we work through these example problems. So again, today we are just practicing finding antiderivatives by using integral notation. And then next class, we will look for area under a curve on a given interval. But I had to show you what they actually do, other than us plugging and chugging away. Okay, so let's get started. Let's have some fun. Number one, you have the integral of 7 dx. Well, 7 is a constant, so the integral of 7 dx is just going to be 7x plus c. This used the constant rule. There you go. And to check your work, you can take the derivative of our answer. Well, we know that the derivative of 7x is 7. And what is the derivative of any constant?
0.
0. Good. So it checks out. Okay. So to check your work, you can take the derivative of your answer. All right. Number 2, the integral of 8x dx. So what I'm going to do with this one is I'm going to take that coefficient of 8 and put it outside the integral. And I'll have the integral of just x dx. So we are now ready to find the antiderivative. And for this one, we're going to use power rule. So we know that the power on this x is 1. So when we find the antiderivative, this 8 will stay outside. I'll put brackets to be neat. And when you use the power rule, it's going to be x to the 1 plus 1 over the same exact thing, 1 plus 1. Okay. Let's go ahead and clean this up. And you'll get 8 times x squared over 2, which will reduce to 4x squared. And don't forget to tack on the c. And again, check your work. What is the derivative of 4x squared?
8x.
8x. Does that check out?
Yes.
For sure. All right. Here, I'll do this. This was... I broke it. I went too fast.
Way to go.
I went too fast. There you go. Okay. 3, same thing that we did above. Here we have the integral of 9x squared dx. So we are just going to take out that 9 and have it times the integral of x squared dx. And now the integral is ready to go. We are all set to find the antiderivative by using power rule again. So here you'll get 9 times x to the 2 plus 1 over 2 plus 1. And you'll get 9 times x cubed over 3, which when you reduce, you'll get 3x cubed, and don't forget the c. There you go. And again, you can check your work. The derivative of 3x cubed is 9x squared. Okay. So there's our first page. Any questions so far? All right, we're good. I got a thumbs from Amanda. The brown thumb. So yeah. All right. 4. We have the integral of x to the -3. Once again, power rule it. So you're just going to get x to the -3 plus 1 over -3 plus 1. And we get x to the -2 over -2. Now, I hate negatives in the denominator. So what I'm going to do here is make it look prettier. I'm going to take x to the -2 and flip it to the bottom. And at the same time, I'm going to take that negative and move it up top, just the negative. So we're going to get -1 over 2x squared plus c. There it is. All right. All right. Power rule. See, the most popular one. Was that 4? Yep, that was 4. 5, yeehaw. All right. The integral of 10 times x to the 3/2 dx. So we're going to move that 10 to the outside, and we're going to get the integral of x to the 3/2 dx. And now the integral is ready. We are ready to find the antiderivative. And once again, power rule. So we'll get 10 times x to the 3/2 plus 1 over 3/2 plus 1. Get your common denominator in the up here and down here. And 3/2 plus 1, that should give me what, 5/2. Oops. X to the 5/2 over 5/2. And now we know we can't have this fraction in the denominator, so we will reciprocate it, or the non-mathematical term of flip. And here we'll get 10 times 2x to the 5/2 over 5. Okay. Almost there. Go ahead and simplify this. That 5 becomes a 1. That 10 becomes a 2. And we will get 4x to the 5/2 plus c. Yeehaw. All right. Everybody good with those two? Why is there so much space?
I was thinking the same thing.
Me too.
Oh, well. Maybe because if I was in person, I'd write bigger on a board. That's not going to happen for a while. Oh.
Isn't it in the fall?
Yeah, but it's not even worth it. It's like right now it's only 50%, and you only get a class of like 7 people.
Tubular man.
Yeah. Yeah. So I was just like, nah, I'll keep doing remote. Whatever. Because I mean, I offered to be face to face, and they're like, "Well, you can't have classes after 5 on campus because there'll be nobody here to sanitize the rooms or anything." So I was like, "Okay."
In other words, there'll be no one to sanitize you.
Exactly.
Just dunk you in a vat of hand sanitizer.
Yeah, because they need like 30 minutes to an hour between classes to sanitize it every time.
Oh wow.
And I was like, "You want to sanitize something? Sanitize that bathroom in Juniper Hall. That thing is disgusting." I remember during the summer, I think it was either during summer or sometime, there was no hand soap in that bathroom for like 2 weeks.
My husband just said they need to burn that building down.
Yeah. There was no hand soap in the bathrooms in Juniper Hall for about 2 weeks. And I had to bring it to somebody's attention, like, "Hey, there's no hand soap." And I'm like, this whole building just infested with germs. It's so
That's
gross.
disgusting.
And then people are using that Dyson hand blower that just blows. I could keep going. I'm not going to keep going.
Yeah, those things are super unsanitary.
Yeah. 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 All right. Yeah. So that's why I'm not in no rush to go back. All right. So here we have the integral of 3 square root x minus 2 cube root of x dx. Okay. So what we have to do first is rewrite the radicals into rational exponents. So I'm going to have this as the integral of 3x to the 1/2 minus 2x to the 1/3 dx. Put parentheses around that to be proper. And now I'm going to split it into 2 integrals just to show you how to do so. So you have the integral of 3x to the 1/2 dx minus the integral of 2x to the 1/3 dx. So we took our 2 terms and we split it into 2 integrals. All right. And I'll use some space on this paper, why not? And now I'm going to take the 3 out. So you get 3 times the integral of x to the 1/2 dx minus 2 times the integral of x to the 1/3 dx. Okay. Oops. Sorry. And now everything is set up, so we are ready to find the antiderivatives of both these integrals. So guess what? Power rule on both of them. So you get 3 times x to the 1/2 plus 1 over 1/2 plus 1 minus 2 times the integral of 1/3 plus 1 over 1/3 plus 1. Add your fractions together and you'll get 3 times x to the 3/2 over 3/2 minus 2 times x to the 4/3 over 4/3. Now flip those fractions and we're going to get 3 times 2x to the 3/2 over 3 minus 2 times 3x to the 4/3 over 4. Clean up one final time. And our 3's will cancel. So we'll get 2x to the 3/2 minus, and then that becomes a 1, that becomes a 2, 3/2 x to the 4/3. And don't forget to tack on the C. There we go. I made use of the space. All right. Everybody good with that one?
Yes.
Okay. All right. All right. 7. We get, I'll move the 16 to the outside, and you'll get 16 times the integral of e to the du. And lucky for us, the integral of e to the u is still e to the u. So you will get 16 e to the u plus c. Done and done. That's easy. All right. Keep going. Number 8. Okay. So we have the integral of 2 plus x squared over 1 plus x squared dx. All right. Well, we don't know how to find the integral in this form yet without some special techniques. So we're going to have to manipulate this algebraically. One thing that we should note is that this integral, the expression inside the integral, looks very close to the integral formula for the inverse tangent. So if we could somehow manipulate this expression to look like that, then we can find one piece of this integral. So what we're going to do here is we see that we have 2 terms in the numerator over the same denominator. So the first thing we can try is splitting it into 2 separate fractions. Why not? So if we do that, we'll get the integral of 2 over 1 plus x squared. And I'll have a parentheses here, plus x squared over 1 plus x squared dx. Okay, we're close, but we still need some more splitting to do. Okay. Well, here's where we get real crazy with our manipulations. So what we're going to do next is, well, before I give it away, I mean, you'd want to try some things first. Like one thing you could do is split this into another integral, as in the integral, and let's just focus on this one right now. You can split it into integral of 1 plus x squared dx, where you could move the 2 out, and it'll give you 1 over 1 plus x squared dx. And we can find the integral of that. But then this would leave us with the issue of this integral, x squared over 1 plus x squared. Well, we have no idea how to find this integral yet, right? And you won't learn it in this class. That's for Cal 2. So in order to fix this, well, what I'm going to do here is, let's reverse. And we are going to take 2 and split. We're going to take 2 over 1 plus x squared and split this into 2 fractions. So this is now going to become 1 over 1 plus x squared plus 1 over 1 plus x squared plus x squared over 1 plus x squared. All right. And of course, we haven't done anything wrong. If we put all of these together, we're back at the original problem. So right now we're just algebraically manipulating it. Okay. So once again, this is good, this is good, this is not good. So to take care of this last piece, what I'm going to do is put these two together. And from here, we should see our integral become a little easier. So you'll get 1 over 1 plus x squared over 1 plus x squared over 1 plus x squared dx. All right. And now, when we simplify this, we're not taking the antiderivative yet. You get 1 over 1 plus x squared plus, and then what does this become?
1.
Just 1. Look how nice that worked out. 1 dx. Okay, so this means that we are now ready to find the antiderivative. I can split it into two integrals, but we don't have to. We can take care of these integrals separately. So from the formula above, we know that the antiderivative of 1 over 1 plus x squared is the inverse tangent of x. Plus, 1 is a constant, so what is the antiderivative of 1? With respect to x.
X.
There you go. Plus c. That's it. That was fun. Okay. So just a little manipulation before we even find the antiderivative. Okay. All right. Number 9. If the second derivative is 20x cubed minus 12x squared plus 6x, find the original function f. All right. So if we're at the second derivative, this means we're going to have to find the antiderivative. What is that? Twice. So our first setup, we'll call this A, is that if we're looking for the derivative, the first derivative, then to set this up, it's going to be the integral of f double prime of x dx. And we know what f double prime is. It's everything above. Okay. So when we set this up, we'll get the integral of 20x cubed minus 12x squared plus 6x dx. All right. Well, this integral is ready to go. And on all three terms, we will use power rule. So no more writing it out step by step. Let's see if we got this. So when I use power rule, I'm going to get 20 times what is the antiderivative of x cubed?
X to the 4th over 4.
There you go. Minus 12 times what's the antiderivative of x squared?
X cubed to the over 3.
There you go. One more. What's the antiderivative of x?
x squared over 2.
There you go. And then why not tack on the c for good habit, and let's clean up. We're going to get 5x to the 4th minus 4x cubed plus 3x squared plus c. Here is the first derivative. Which means now we can go ahead and find the original function f. So b, f of x is going to equal the integral of f prime of x dx, which will give us the integral of 5x to the 4th minus 4x cubed plus 3x squared plus c dx. Okay. This integral is ready to go. And once again, power rule on all three of these, and then constant rule on the last one. We are ready to go, guys. 5 times, what is the antiderivative of x to the 4th?
X to the 5th over 5.
There you go. Minus 4 times the antiderivative of x cubed. We
X
saw
to
that.
the 4th over 4.
Good. And then the antiderivative of x squared.
X cubed over 3.
X cubed over 3. And then constant rule on the c. What are we going to get?
Plus X.
Cx.
Squared. Oh, CX. Okay.
Cx plus d. We have to add a new constant of integration.
What did we add at F?
If you wanted.
Okay.
Whatever
So it
letter
just has to
you.
be
I just
11.
didn't know if I didn't know if there's some rule to go C, D, E.
No, I would just keep it in alphabetical order, but I mean, whatever letter you choose is fine. Just don't put another C. If you
Okay.
want to get technical, you could say C1 and C2. But C and D is fine. Okay, clean up. And you get x to the 5th minus x to the 4th plus x cubed plus cx plus d. And there's f of x. Yeehaw. Everybody good with that one? Got the thumbs. We got the thumbs. Okay. Next one is just like it. But this time they're giving us values to plug in. Okay. So 10. If f double prime of x is -2 plus 12x minus 12x squared, and f of 0 is 4 and f prime of 0 is 12, find the original function f. Okay, same steps here. So I'll say A, find f prime of x means we get the integral of f double prime of x dx, and we'll get the integral of -2 plus 12x minus 12x squared dx. That integral is all set and ready to go. So here we will use constant rule and then power rule in the last two. So we should get -2x plus 12 times x squared over 2 minus 12 times x cubed over 3, tack on the c. And then negative 2x plus 6x squared minus 4x cubed plus c. And this is f prime of x. But what value are they telling us to plug in for x in order to find c?
0.
0. Good. So if we plug in 0, lucky for us, that 0, that 0, that 0. So they all cancel and leave us with c. But f prime of 0 is also what value?
12.
12. So 12 equals c. Perfect. This means that f prime of x is negative 2x plus 6x squared minus 4x cubed plus 12. There's the first derivative. And now we want to find the original function. The integral of f prime of x dx. And we get the integral of negative 2x plus 6x squared minus 4x cubed plus 12 dx. Okay. Power rule on first three, constant rule on the last one. Okay, we're ready to go. Negative 2, antiderivative of x squared over 2, plus 6, antiderivative of x squared, x cubed over 3, minus 4, antiderivative of x cubed, x to the 4th over 4, and then antiderivative of 12 plus 12x, plus 12x, and here you can tack on c again, d, whatever value you like. Okay, clean up, and we get negative x squared plus 2x cubed minus x to the 4th plus 12x plus c. Here is f of x, and again, they're telling us to plug in what value?
0.
0. So f of 0 means 0, 0, 0, 0. And we are left with c, but f of 0 is 4. So we get 4 equals c, which means that f of x equals negative x squared plus 2x cubed minus x to the 4th plus 12x plus 4. Yeehaw. Cool. All right. All good on that one. Sweet.
Good.
What's left? That. Oh, look at that. 1, 2, 3, 4. You want to do those last 4, Ryan?
Sure, why not?
All right. I'll do number 11. And then you can do the last 4.
Okay.
Make you work for your money.
Don't kid
Alright.
yourself. You guys don't pay me.
All right. So here we have the integral of 5x times 1 minus x dx. All right. So what we're going to do here is distribute the 5x first. So we'll get the integral of 5x minus 5x squared dx. And we can split into 2 integrals, but now we know we don't have to. This integral is ready to go. And it's going to be power rule on both of them. So we are going to get 5 times the antiderivative of x squared over 2, minus 5 times antiderivative of x squared, x cubed over 3. Tack on that c, why not? And we will get 5 halves x squared minus 5/3 x cubed plus c. Boom. Boom, boom. Not bad. All right. How are we doing so far, guys? What do you think of antiderivatives?
Seems easier than regular derivatives. We're learning how to do derivatives.
Just wait.
Wait till Cal 2.
Yeah.
These get a lot worse, but if you know your trig and algebra, you'll be fine. So yeah, like we always say trig, you'll see trig, we saw trig in this class, wasn't crazy, but you'll see trig in Cal 2 and it gets pretty insane. You'll get something like, what is it, Ryan? Like the integral of cosine to the 4th x and sine to the 5th x dx.
Yeah.
And you have
like
to, yeah, you have to make like substitutions on substitutions on substitutions to find this integral.
Then you guys learn trig sub,
Yep.
which is using trig to simplify an integral.
Oh boy. All right.
Fun stuff.
Tapping you in.
Put me in, coach.
You're in.
Why is
Or
it-
not.
Hold on. OneNote wasn't showing up. Let's see if it
Oh.
works now.
Bogus.
There we go.
So I did a OneNote training on Tuesday and yeah, only one person showed up because they forgot to send the email out to everybody.
Really?
Yeah. So, 'cause I told the host too, and I was like, did you send an email out? She goes, I thought I did. I was like, I didn't receive anything. I was like, I had to look up last week's Zoom link to join, and only one person joined, and they were having problems because they have a Mac. And I was like, all right, well, to fix your problems, throw away your Mac.
I agree. I wholeheartedly agree.
I was like, you shouldn't be using Microsoft programs on your Mac. Okay.
It's like, what is this virus? Self-destruct.
Cool. All right.
Okay. So looking at this integral, it kind of looks a little different than what we had previously because we have the du as the numerator of a fraction, but we can just simply rewrite that by saying 1 over the square root of u times du. And then referring back to the antiderivatives from the beginning of the lecture, there's nothing we have that would give us the antiderivative of this integrand, but we can manipulate it, right? So remember that we can rewrite the square root as a 1/2 exponent. And then using power properties, I can reciprocate this u, so meaning I can bring it up to the numerator by switching that 1/2's coefficient to a -1. So now we'll have u to the -1/2 du. Now this is just a power function. So all I have to do is add 1 to the exponent. So now my base will be u to the -1/2 plus 1 over -1/2 plus 1. And then finally plus c. So now simplifying my exponent, -1/2 plus 1 will just be 1/2. And then again, -1/2 plus 1 is 1/2. Now our denominator is a fraction. So the whole fraction is a complex fraction. So to simplify this, I just reciprocate my denominator. So this will be 2u to the 1/2 plus c.
Yeah.
Easy peasy lemon squeezy.
Amanda applauded you with her brown hands.
Oof. Now what are we gonna do for this one? Is it okay to simplify the numerator first? And then reduce the denominator?
Either way, you'll get it because
Okay.
you want to, I mean, you're going to have to split it into 2.
Yeah, I just don't know if this was like a Robert Sneaky problem.
No. Not like the one we did earlier. That one's too sneaky. We have to split 2 into 1 and 1. That's just crazy.
Yeah, that's meaningless.
Yeah. Out of the box thinking.
Okay, so again, referring to what we learned in the beginning of the lecture, there's nothing we have to solve this integral as it is. So we need to think about simplifying algebraically. What I see is that we have 2 terms in our numerator, and they're both being divided by a common denominator, meaning I can separate these 2 terms as 2 separate fractions. So we have 2x to the 4th over x cubed minus x over x cubed dx. And then now I can just reduce. So x cubed will reduce this x to the 4th. And this x will reduce this x cubed. So my new integral will be 2 over x minus 1 over x squared dx. Now we have our integrand is separated by a sum or a difference. So our
I
solution,
have a quick question.
what's up?
So the 2x x to the 4th over x cubed, isn't that 2x
Oh,
over
sorry.
1?
Right, that's right.
Thank
My
you.
bad.
I was gonna ask the same thing.
2x. Sorry about that. So now again, we have our integrand separated by a difference. So we can take the antiderivative of the first and subtract it by the antiderivative of our second. So the antiderivative of 2x, well, we can ignore the constant coefficient. And then now you'll have a power function. So you have x to the first power plus 1 over 1 plus 1 minus And then here, remember, we're going to have to rewrite that. So remember, 1 over x squared is equal to x to the negative 2. So the second term will be x to the negative 2 plus 1 over negative 2 plus 1. And then finally plus constant of integration. Now simplifying all my exponents, I'll have 2 times x squared over 2 minus x to the negative 1 over negative 1 plus c. Now simplifying my coefficient, and then this will become a plus, and that will reduce that negative 1. So now we'll have x squared plus x to the negative 1 plus c, and then rationalizing my negative exponent, and that's it.
Yeehaw. Oh.
Another one. Oh my god. You're doing this to punish me, aren't you?
Yeah.
The same one over. Now let's get you guys involved. This is the same as the previous problem, right?
Yeah, almost. Well, yeah, same concept.
Right, so this is like a big thing you need to learn to do for calculus 2 is pattern recognition, right? So ignoring things like coefficients, right? Isn't the structure of this integrand very similar to this integrand?
Yes.
So what do you think our steps should start with?
Separating the two fractions to the same denominator.
Good. And this is kind of like how you learn to do integrals. Is you see something that looks similar to what you've done before. So the idea is just, well, try what I've done before. And if it works, there you go.
That's literally what I've been doing all semester.
Right? Yeah.
Me too.
Unfortunately, calculus 2, there isn't as much formula as there is to calculus 1. So you kind of do have to kind of take a guess and see if it works out. Okay. So like you guys said, we start by separating our integrand into two separate fractions. Now x to the 4th will reduce this x to the 5th, and this 2x will reduce that x to the 4th. So now we have x minus 2 over x cubed dx. So integrating this, again, remember that 2 over x cubed is 2x to the negative 3. So this first term, if I integrate it, that's going to be x to the 1 plus 1 over 1 plus 1 minus, and again, this is a constant coefficient, so I can ignore that. And then now I'll have negative 3 plus 1 over -3 plus 1. And then finally plus our constant of integration. So my first term is going to simplify to 1/2 x squared minus 2 times, then we'll have x to the -2 over -2 plus c. And then we have a -2 being divided by a -2, so these will reduce. And we'll have 1/2 x squared plus x to the -2 plus c. And then our final rewrite will be 1/2 x squared plus 1 over x squared plus c. Sweet. Oh my God, you do hate me.
Hey man, they're easy.
Okay. So what do you guys think? Does this look similar to the previous two problems?
Yes.
It does, right? Two terms separated by a sum or difference, and they're being divided by a common denominator. So let's just try what we've done in the past two problems. See if it works. I need to write a complaint to my supervisor.
He's checked out.
Okay. So separating my numerator into two separate fractions, I now will just reduce. So I see this x squared will reduce with x squared, and this x will reduce that x squared. So now we have the integral of e to the x minus 2 over x and then dx. And then again, remember, two over x is equal to 2 times x to the -1. All right. So what would the antiderivative of e to the x be?
E to the x.
Right. So remember, your integrand is the derivative of some function, right? So you can also think what function's derivative is e to the x. E to the x, right? And then taking the derivative of this term, so we have -2 times x, but we're going to run into an issue here. See if you guys can tell me what's wrong.
Denominator is going to be 0.
Right. So this is a trick I see a lot in Cal 2, or this is a mistake I see a lot in Cal 2. This is an instance where power trick can get you in trouble, because this essentially becomes, the second term becomes -2 times x to the 0 over 0, right?
Yes.
Which doesn't quite make sense, because remember, we're taking the antiderivative of some function, right? We can just say this is f of x. Well, if this function is the derivative, that means there should have been an original function, right? And this isn't a function at all. This is undefined, indeterminate, whatever. Yeah, it's undefined. So in that case, power trick won't work here. So we need to kind of think backwards in a sense, right? This function is the derivative of some function of x. So let me rewrite this. Ignoring that constant of integration, we can say this is equal to 2 times 1 over x. Going back here, we'll say that this is this, right? So I haven't taken the antiderivative quite yet, but I manipulated this negative 2 over x to be something that we can maybe recognize.
ln of x, or the natural
Good.
log.
So if you refer back to the beginning of the lecture, this is a given antiderivative. The antiderivative of 1 over x dx is just natural log of x. Or again, if you're thinking backwards, the derivative of natural log of x is 1 over x. So that would be our solution. In this case, we actually have to use the absolute value signs if we are taking antiderivatives. Did that make sense?
Yes.
Cool. So this is like one of those instances where if like you try just applying a formula, it may get you in trouble.
All right, that was good.
That's it.
And that's
Wow.
it. That is, wow, what section is that? 4.7.
7.
So that's intro to antiderivatives. So next class, we will be using something called evaluation theorem, which is the first part of the fundamental theorem of calculus. So we will be evaluating integrals on an interval to find the area of a function. Okay, but that is 4.7. So we are done.